On with the lecture 3. The glass transition, as I mentioned, is a temperature above which the material becomes leathery or pliable above this temperature. But there is a slightly better definition of what is the maximum use temperature for, especially in the case of a composite, and that is the heat distortion temperature, or HDT, and it is defined by the deflection temperature under a specific load test under ASTM standard D648. It is not a thermal transition like glass transition or melting point, but it defines the maximum use temperature, which is a better definition of what is the maximum use temperature for a composite material. And it bends a specified distance under these conditions is the SDT. Now let us coming to the difference between thermoplastics and thermosets. So the standard definition is that a material or a matrix that cross-links inside the matrix is a thermoset when you apply a temperature, an increasing temperature, and one that does not cross-link but just melts and or cools down, or solidifies when you cool it down, is a thermoplastic. So how do you define the change in mechanical properties versus curing time for a thermoset? You look at the thermogravimetric weight change, or you look at the mechanical properties under the DMA test, and the temperature at which the mechanical properties become stable is the curing time for a thermoset material. Now, the other aspect of thermoset is what is the time it takes for the curing onset in a thermoset material. So suppose you have and that is also going to define the time you have in order to apply pressure or whatever. So beyond which it is not going to, once it cures, nothing you do is going to make any difference to that material. But till that time, you might apply some kind of a temperature and pressure and things like that in order for it to cure completely. So suppose you look at of a thermoset material at two different temperatures. So if you apply a higher temperature, it will cure faster and you get less time to handle the material or to place the material in the mold, etc. Whereas if you use a lower curing temperature, it gives you a longer pot life and much more freedom to move it around and things like that. Now, that will also depend upon the type of thermoset matrix. Different thermoset matrices are defined, the curing temperature or the curing profile is defined by the manufacturer, and they sometimes tell you, hey, you apply this at this temperature, you have say 30 minutes, but if you go to a higher temperature, you may have only 5 minutes or 10 minutes. So it depends upon the what the manufacturer has suggested. For thermoplastics, you have a couple of different composite processes that you can use. The first one is obviously extrusion. The next one is injection molding. You can inject this thermoset matrix and the fibers into a mold, or you may apply some kind of a blowing compound or a blowing pressure in order to blow that into a mold, and you may have a mold around which it will go and stop. Or you may have a process called thermoforming, and you have a couple of different types of thermoplastic materials. I would advise you to look at the Center for Composite Materials at University of Delaware's website for other processes being developed for thermoplastics. For example, one of the processes that they developed is based on induction heating. And I will explain that in the slides going forward. Now, there are cross-linking reactions taking place in a thermoset type of material. It restricts the movement of the polymer molecules, and it strengthens the material. The cross-linking also increases the glass transition temperature, and so any characterization process that can monitor the glass transition can monitor the cross-linking or the curing. So for example, you can use DMA or DSE, or for example, you can also use TGA in order to monitor the weight loss as well as the cross-linking. And the cross-linking gives away the uh, atomic species that are not linked strongly, and so that will increase the molecular weight. I mean, it will decrease the weight, but it will increase the molecular weight of this material. So this one is a schematic uh, of a thermoset material. So if you have a low molecular weight polymer, it will, from the solid point onwards to the decomposition point onwards. So whether it is a low molecular weight or a high molecular weight, its melting point or freezing point will be different. The temperature up to which it is solid will be different, but the charring temperature and the decomposition point is very close to one another. So this is a schematic. It could be slightly different over the period of time. So this was the process that I was telling you about based on induction heating. This was developed by the Army and the Center for Composite Materials at University of Delaware by Jack Gillespie and his group. Basically what you're doing is you can apply some kind of a pressure. At the same time you're applying temperature through induction heating. Induction heating is much faster, and it can occur through multiple stacks or fabric. So you have an alternating current, and it applies some kind of a induction heating pattern, and especially if the fiber is slightly conductive, like based on carbon fibers, so that is a much better method rather than glass fiber. Glass fiber, it may not be easy to do induction heating. You may need to add some kind of a metallic inclusions or ingredients in order for it to be able to be processed using induction heating. So this gives you some additional information about the thermoplastic composite processing. I won't go too much into the depth of that. I took some of that information from the University of Delaware folks to figure out what exactly is the process. Okay. So again, I will stop here for this set of slides. I will go to the next set of slides in the next one.